Hello everyone, and welcome to the second session of this lecture series entitled Excel in Structural Engineering. Today we will start learning how to develop an Excel template to be used for the analysis of rectangular singly reinforced concrete beam cross-sections. And thus, we will be trying to duplicate the Excel template shown on screen and presented during the previous session. Let's get right into it. I'm going to start a new Excel sheet. Select all the cells on screen and assign font 14 to all. I'm going to start at the top cell of column B here. Select these 4 cells and merge them together in order to create an input parameter zone. I'm going to insert the text input parameters. And I'm going to give this merged cell an orange color. I'm going to increase the width of column B so that it will be capable of encompassing all of the descriptive sentences here. The first input parameter will be the width of beam. The letter assigned to the width of beam is small letter b. I'm going to add an equal sign here. The default value that will be presented whenever the template is initiated is 300 and its units are millimeters. We can assign a yellow color to all of the text cells and a light blue color to the actual input cells. We can select everything and assign center to all. In order to save your time, I'm going to just copy the rest of the input parameters from the original template here and paste them in the newly created sheet. I'm going to further increase the width of this column to be able to encompass the descriptive sentences. I'm going to copy the figure as well, put it here. And there you have it. Now the input parameters section is ready. I'm going to shift a couple of columns and start at the first cell of column H here. Select these 4 cells, merge them together in order to create an output parameter zone. Insert the text output parameters. Give this cell an orange color. Widen this column a bit. And again, in order to save time, I'm just going to go to the original template here and copy these descriptive sentences. I'm going to copy the symbols as well. And copy the units. Note that some of the input parameters do not have units because they are unitless, such as strains and ratios. Now for the actual output parameters, I will assign the color light blue. I'm going to merge these 3 cells here and assign a light blue color to them. And there you have it. This is the easy part where we just copied the text and the formatting from the original template. Now we are ready to start the actual engineering part where we need to use our input parameters in order to calculate our output parameters through the formulas and equations that will be presented next. Please pause the video and take a couple of minutes to read the descriptive sentences of all the input and output parameters to familiarize yourself with these parameters of reinforced concrete and their chosen symbols. In Excel, you can store the number 12 in the address D16. This is D and this is 16, so in D16 I'm going to store the number 12. I can also store the number 28 in the address D17. Then I can ask Excel to find the sum of the values stored in the addresses D16 and D17 and store the result in the address D18 by clicking on the equal sign and then summing D17 plus D16. Now if the value stored in the address D16 is changed from 12 to 30, then the sum that we have just calculated will change as well. If you try to assign an address to another address, for example, if you say that D22 here is equal to D16, then what you are actually doing is you are assigning the value that is stored in address D16 to the address D22, which means that the values stored in addresses change, but the addresses themselves, they do not change. Why am I bringing this subject up? Well, there are two ways to write our equations and formulas in Excel. The first way is to use the cell addresses in our equations, and the second way is to assign names to our addresses and then use these names in our equations. Let's explain these two ways or methods through an example. Say that we want to calculate the area of concrete in our cross-section, which is equal to the width of the cross-section B times the total depth of the cross-section H. In the first method, we will say that the area of concrete in the cross-section is equal to, and we will store the result in the address E14 by clicking on equal and then clicking on D2 times D3. By clicking enter, we will get the area of concrete within the cross-section in millimeters square. Note that in this first method we are relying on addresses to obtain the values stored in these addresses. Another way of doing it is to assign names to the addresses in Excel such that the previous equation can be rewritten as here, the area of concrete in the cross-section is equal to B times H. Now this is very beneficial because then we can write the equation in Excel just as we would write it on a piece of paper while we are solving the analysis by hand. Now if I click enter, nothing will happen because B and H have not been assigned to addresses yet. How to assign names to addresses? It's quite straightforward. Click on the address that you want, which is D2, and here give it the name that you want, B, and click enter. Now if you click on the same address again, you will see that this address has been assigned the name B. Let's do the same thing for D3, but this time I'm going to call this here HT, which is not the symbol that we are using or we're going to be using here, but just to show you how to edit names. Now if you click on the address again, you will see that its name is HT and nothing happened here because in this equation we have B times H, not HT. So let's say that you've entered a name and then you've realized that the name that you have entered is not correct. You can easily edit the names that you have assigned through the formulas menu, going to the name manager, and from here you can either add new names or you can edit names that are already assigned, and you can delete any of the names that you have assigned. For example, let's click on HT here and edit this name to be H only. Click OK and then close. If you click here, you will see that this address has been assigned the name H and the value has been calculated without referring here to the specific addresses. So again, we have two methods. You can either directly insert the addresses here and multiply them by each other to have the area of concrete in the cross section, or you can assign names to the addresses that you want, and then you can write the equations just as if you would write them on a piece of paper. A couple of remarks about names that can be used in Excel. You cannot use the letter C, either small letter or capital letter, and you cannot use the letter R, either small or capital, as these letters are reserved for column and row respectively, and thus they cannot be assigned as names in Excel. Another fact that you need to take into consideration is that you cannot use a certain address as a name for another address. For example, if you click here on D3 and try to assign the name H1 to it, once you click enter, the cursor will go to the cell H1 and nothing will happen here, as the name of D2 remains H, because you cannot assign the name H1, which is a destination, an address, to another destination or address, which is D3. And therefore these 2 points should be taken into consideration when you are trying to assign names in Excel. We will continue assigning names to the rest of the input parameters. We have already assigned the name B for address D2, which is the width of beam. We've assigned the name H to address D3, which is the depth of beam, and now we will continue. For the yield stress, I'm going to click on its value here, and in the name zone here I'm going to insert Fy. For the compressive strength of concrete, I'm going to use Fc prime. For the diameter of bar in the layer farthest from the neutral axis, I'm going to use dBb. And for the diameter of bar in the layer on top of it, I'm going to use dBt. Now, if the beam is carrying a negative bending moment, you know that the steel will be placed on the tension side, which will be at the top of the beam, opposite to the one shown on screen. Then the nomenclature of saying that the layer farthest from the neutral axis and the layer on top of it would be wrong. But here I am indicating that we are working with a section carrying a positive bending moment, so I hope that you really understand what I'm talking about. Let's continue. We have finished the diameter of bar for the second layer. Next, we will define a name for the number of bars in the layer farthest from the neutral axis. That's going to be NOBB. And the number of bars in the layer on top of it, which is NOBT. For cover, I'm just going to use the same word, cover. And for the diameter of stirrups, I'm going to use DS. Let's go through them quickly. This here is B, H, Fy, Fc prime, dBb, dBt, NOBB, NOBT, cover, and DS. Again, if you made any kind of mistake while trying to name your input parameters, you can easily go to Formulas, Name Manager, and you can edit, you can delete, you can change whatever name that you find not to be suitable. In the next session, we will use the input parameters with their proper names to define our equations and formulas used to obtain the output parameters and make this Microsoft Excel template fully functional.